Hey guys, welcome back to MMH. We're in the garage again today. We got, as you can see, Red Racer in the background here, 2004 Chevrolet Aveo. Last video on this thing you saw, we did all the suspension work. We got this thing driving nice again, smooth, buttery smooth. And that's all fine and dandy, but we still got some problems with this thing. It has a check engine light on, which is a few issues that it has going on. But the gas mileage is abysmal on this right now. It's getting about 9 liters per 100 kilometers. We could convert that to miles per gallon. Maybe I'll try and toss that on the screen if that's the number you care about. But that's bad for this little car. I mean, you're not buying this car to cruise the strip, you know, to look cool, to go fast, to have fun. This is just a car that's supposed to be cheap and get good gas mileage. It exists for those two purposes alone, and it's failing at that right now for its only reason to exist. So we want to get that fixed. So first things first is going to be looking at those check engine lights and seeing what we can solve. That's probably going to be part of our issue. So I've got the Autel there loading up a scan right now, and I'll show you the codes we're dealing with, and we'll dig into it. Okay, here we go. I got you zoomed in on the scanner so you can see what we're doing here. Let's see. First things here, we got a few codes. EGR position sensor, circuit, low voltage. So that's not one I'm extremely concerned with right now, because there was a couple other ones I wanted to look at. We will dig into that, but it's not the first one I want to look at. So then we have this P0449, which is an evaporative emissions vent solenoid valve control circuit. Now that is the vent valve off of the fuel tank. That is one I definitely want to get into. So something like this, don't just go buy yourself a solenoid immediately. There's a few things we can check before we just do that. Spoiler alert, I already know what's wrong with that one. It's a simple fix. But again, not the first one I want to deal with. Go figure. The last one on the list of our 3 codes is this one that I'm most concerned about, the P0660, which is this intake manifold tuning valve solenoid control circuit. Now, I can go ahead and get this out of the way. That one here, and this is going to be pretty similar on all kinds of cars. Let's back you out here so we can see what's going on. Okay, here we are, set up a little better camera angle for you. Now, on our intake manifold right here, there's some runners inside, some flaps that move so that you can control your airflow and get more airflow essentially when the engine's at higher RPM or needs more power. Now, that P0660 is related to this solenoid right here that controls those valves. It uses vacuum to control that. And if that's not functioning, well, then we're not getting the proper amount of air potentially at higher RPMs, which if we're under load and stuff like that, and you can't get enough air, now you're burning rich, too much fuel, you're not getting a proper combustion, and that's going to burn more fuel. So this could potentially be the source of our horrible fuel mileage. So I want to get into this. I got to dig a little bit there, but I've got a wiring diagram. And first things first, that's going to be really important whenever you're looking at any of this stuff, is you're going to want a diagram to understand how the system actually works. Because, you know, the typical YouTube fix is going to be what? It's, oh, there's a code for this valve. Okay, just buy this valve, replace it, problem solved. Well, a lot of times it's not problem solved. So you just waste money on parts, you waste your time changing things. So I'm going to go ahead and break out the meter here, and I don't know if I'll put the schematic up on here. It's a pretty simple schematic. I might just go through it here with the meter and show you what I'm doing and how the circuit works. All right, so the first simplest step that you should do, which is even right from GM, they tell you to do this in the troubleshooting guide. If you read the guide for this specific code, is to use your scanner to just command this circuit on. You can command it at certain percentages and stuff. Now, for some reason, I can't find that in my Autel. These Autels are so hit or miss. Sometimes they have everything, and for some cars, they're just missing stuff. So You know, I can do a lot of the command for the EGR and the intake air control, but for some reason, there's no option in there to do a control on this intake tuning circuit. So all I can really do is confirm the integrity and function of the electrical side of this circuit. And if everything checks out good there, then, well, I mean, the solenoid's bad. That's pretty much the easiest way to say that. So I did unplug this from the back there. You're not going to be able to see it. It's just in a bit of a cave. So it's just to plug 2 wires, unplug that. The red, I don't know if you can see the colors here. One's yellow. So the yellow is our control side. And this looks red. The schematic says that it's brown, but it's not yellow. So I can assume that that's the other side of it, which is just simply ignition supply voltage, which is just going to be battery voltage. So it should be about 12 volts. So we can just go ahead and we'll check for 12 volts there first. Get her on direct current. There it is, 12 volts, just like we're supposed to have on that ignition side. Okay. Now, the way this circuit works, you get battery voltage, essentially, ignition voltage coming in the one side. The other side, your control side, this yellow, runs back to the computer. The computer just pulls this side to ground as much as it needs to create a loop in that circuit and pull as much voltage as it needs to get the output it wants on that actuator. So we should have a connection to ground with this, continuity with ground, and we shouldn't have continuity with ground on this side. This is just our supply voltage. So we'll go ahead and check that. Okay, our yellow side, yeah, continuity with ground. Let's check. We do. We have continuity with ground, just like we should. Now, what we shouldn't have is continuity with power. Like I said, the computer pulls that whole power circuit down to ground, and that's how it creates a full circuit to actually have voltage in the system. So, right now, being that this is unplugged, there shouldn't be any way to have a continuity with power on that side. So if we did, that would be a short to power. We can check that. And no, we're open. We have no continuity with power. That's good. Now, is there anything else we could check with this circuit? We shouldn't have continuity with ground on the power side, the ignition side. No continuity with ground there. That's good. That would be a short to ground somewhere in the circuit. So we've got continuity with ground where we should. We don't have it where we shouldn't. We've got ignition voltage on our supply side. We checked everything else when it was running. It's like this whole circuit, as far as I can tell, is working. Now, if I really want, like, that pretty much tells me right away that the solenoid's bad, and it's a cheap solenoid. So I pulled this off the car already, just in case I needed to. So this is it here. This is the actual electrical solenoid. Your power comes in here. Once that computer grounds that on that yellow wire, it opens this a desired amount, right? It can control that voltage based on how much grounding it's doing. And then you've got your vacuum lines here. This is just a vacuum accumulator that holds vacuum. And that will send that out to that actuator, which is there. And that can move your runners. And I don't know if you can see in there, but there's a little rod down here that's attached to on the intake manifold, and it just sucks that in basically with vacuum. So this is the part that we're assuming is bad here now. If all of our power circuit works, that's basically the culprit left there, is that this just isn't responding to the power that's being supplied to it. So if that's the case, we'll replace that and move on with life. And ta-da, just like that. We got our part already. I say already, it's been over a week because I had to go to work while I was waiting for this to show up. It is a GM Genuine. And let's see, what is this? 25183 13354 is the number for this. And go figure, this the actual OEM part from GM was like half the price of the Chinesium knockoffs. They were like 40 bucks. This thing was only 20, I think. So I'm not going to complain with that. Always try to use the OEM part whenever I can. You know, I doubt you're going to be able to see me digging in there again, right? Put some light up, but it should all be nice and loose here because I left it loose to get at, if you recall me saying, which was only like 30 seconds ago for you. So weird sometimes to film this stuff because for me, time goes by, but for you guys, it's happening live. It's all going on right now. So I forget what I said to you last week sometimes. Okay. Now, the only real bugger about this is, like I mentioned, that my Autel, I don't know why, that's the one function it doesn't seem to have, is testing this valve here. So I won't know if this works until we go ahead and just drive the car and see if the code clears or stays cleared, because I'm going to clear it myself. But pretty sure that's no good. Throw it in a box for now. The other thing I should have mentioned is this is the actual vacuum actuator for that, for the intake runner. What we can do is just hook a vacuum gun to this, put some vacuum on it, and make sure it pulls the lever. I already did that off camera, but that's how you would test to make sure it's the solenoid and not this actual valve here. So I know that's good. The solenoid should be the only thing left. I think we're in good hands, but you never know. Go for it. We're recording.
Okay, so Mav and Dad are on here, and we just ripped up our deck, but we're about to finish this car so we can go to our place where you wash your feet. And then welcome back, crew.
All right, great. Good one. Okay, the next code that we wanted to tackle on this thing was to do with the evap system here. It's the vent valve off of the fuel tank. Now, before you just go order a vent valve and figure, hey, let's replace that, we're just going to go take a look and examine our area first and see if we don't see anything out of whack. And even before we would order a part, we would go ahead and test its function and all that stuff, test the circuit. So let's go look at the area and see what we see.
Yeah.
Now, this little go-kart here, pretty easy to access. I already pulled the wheel off, and this right here is our vent valve right here from the fuel tank. Now, what do you see immediately? Got a plug here, and we've got what I'm pretty sure is the wiring that goes to this. It's completely ripped off. So that would be a good reason why that wouldn't function and set a code for us. So pretty simply, first thing first, we're just going to repair this wiring here. And I've got a little pigtail that I picked up from Pick and Pull that I just yanked off another car. We'll splice that in. You probably don't need to see that. I hope you know how to splice wires. If you need me to show you at some point in the future, go ahead and throw it in the comments. We can do a splicing video. So let's repair that and see then if our vent valve will function.
You can't see me.
I can see you.
So, hey crew, we're back again. But did you know we can see the wire there? Out to the end a bit. So we just used the heat gun, which is pretty hot. So that's why you never want to touch those things. Yeah, on the head it's too hot, so we gotta let it cool down. Then we'll tape that back together. Then we'll put the wheel on. Then we're going to go to our place where you wash your feet.
Yeah.
So that's what? And Mav and Dad are on the air.
Well, there you go. All right, so here we go. This is our spliced connection. So easy, even a 5-year-old can explain it to you. So we just went ahead, we matched the wires up because I cut this right off this exact same car at the Pick and Pull. We use these heat shrink connectors, which are actually great. I don't know if you can see that. They've got solder in them. Melts right into the wire. It's great. Seals them up on the ends there so they're all weatherproof. And we'll just go ahead and tape this up, plug it in, and good to go. Now, the reason that was ripped is when I bought this car, the guy that had it had tires that were way too big on here. So the width of them was sticking right in, and it was making contact with this harness the way it was hung out here. I replaced it earlier and hung it from the back, but there it is, ripped again. So we're hoping now with the right size tires, this should be the end of this problem.
Yep.
Alrighty, next stop on our little maintenance and tune-up fiesta here on Red Racer is tackling this ignition system here. So just to make sure we're burning fuel in all its entirety as much as we can to get the best fuel mileage, we want to make sure that we can supply enough voltage and current to our spark plugs and that our spark plugs are in good shape and everything. So I've got new spark plugs here. We got the G-Powers Platinum. They were just whatever the cheapest one was. I'm not doing copper or anything that cheap, but it's not a hot rod, so we'll just use what we got there. But they're NGK, they're good brand. I got some brand new NGK spark plug wires that we're going to go ahead and replace, because these, I imagine, are probably the same age as the vehicle. I doubt they've ever been replaced. And then a nice brand new Delphi coil. They show a picture of an individual coil there, but that's not what this is. This is a waste spark system with our brand new coil right there. So we're going to go ahead and remove that, replace it. It was cheap enough, so I figured, what the heck, might as well. It's not normally something I just replace for funsies, but since we're already in here, we just want to make sure this thing is producing the best fuel mileage you can. But a little bit dirty in here, so I'm just going to go ahead and clean things up a little bit first. Use some brake clean, spray a little cancer sauce on there. I don't think I have, the worry could be that we have a leaking valve cover gasket here, but I don't believe that's a leak. I think this is just from somebody topping up the oil and spilling it everywhere at one point. You can see it where it was leaking all down around the spout here. So, but that's why it's a good idea to go ahead and clean it up, because if it gets messy again, well, then I'll know that I do have a leaking valve cover gasket and we can replace it. But if it is leaking right now, it's definitely not very bad because it's not all over the place. So let me break out the mold in here a bit. We're not trying to do a detail for a car show or anything here. Just clean up a bit of the mess that's already here while we're in here, just so it doesn't look so bad. Especially out of the center here, because I don't want anything falling into the holes, into the bores when we pull those spark plugs out. All right. Once we get the plugs out of here, we'll fire a little, or once we get the wires out of here, we'll fire a little more air down the holes, just because they should be pretty clean. But do spark plugs first, and I don't know if you could tell, I didn't have to put any torque on that at all, which is good. You don't, I mean, they shouldn't be loose, but you definitely don't want to be torquing these very hard into the head. I'm just going to go ahead and replace them one at a time instead of taking them all out first. Now these are pre-gapped. I'm not going to worry too much about it because it's not like a race car build here or anything. Otherwise, I might put a little more effort into it. Now these ones tell you right on the box when you're tightening them down for a washer type. It says to go ahead and get it hand tight, which is what we have here. It's not a taper neck. It says go ahead and get it hand tight. And then it says to do 1/2 to 2/3 turn on it. That is pretty sure way too much. I usually do it by feel, but let's go ahead and see how much I actually get on it where it feels right. So there's hand tight now. You want to make sure you just go with your finger and do that just to get those threads started and stuff. You don't want to use a power tool for these. If you get that cross threaded, that whole head's coming off to fix that generally. Okay, so we're hand tight. Here I am about, let's see, I'm almost perpendicular here with the valve cover. So let's see, 1/4 turn would get my handle out to here. Let's see if I even get that. Oh yeah, okay. See, this is the first one though too, where we're crushing the washer. Once if you ever had to remove these again, the washer's already crushed, you would not need as much turn on these. So there's a 1/4 turn. There's a 1/2 turn. That still doesn't feel. And then that's about right there. That's like 3/4. So that's even a little more than they say on the box. I thought what they were saying on there sounded like way too much, but who knew? All right, spark plug's done. Yeah, and they do actually have it marked on there. You probably won't be able to see it. There's a 1 and a 4 and a 2 and a 3. So that's how they're paired up. They always fire both of these at once. That's a waste spark system is what they call it. There's that. Get these out of here. And we will go ahead and yank this coil off. There's just one plug for the coil. Well, you can see the new coil here. This is where the main plug goes into it. It's right at the bottom. Down there. Let's go ahead and clip that. Finally found the right tool. My 1/4 inch ratchet got up and walked away on me. Just 3 mounting bolts for this. They're actually mounting nuts. Sometimes I feel like I'm going nuts. It's one thing with driving junky old cars, man. It just feels like it never ends. There's always something that needs to be done. Now, try not to put our nuts somewhere where we don't lose them. Now, let's see here. There's our coil plug, just a little lift clip from the bottom. Get that out of the way. Now, I'm sure I could keep that for a spare if I really, just in case for some reason I needed it. Our plug looks good. Nothing worn out there. I did actually find a big shot show of wiring in here a long time ago when I had an issue with this car. Looks like somebody maybe swapped an engine at some point and didn't know what the heck they were doing, putting everything back together. Now, these plug wires came with some dielectric grease there with them, and you'll notice I didn't put any of that on yet. You can put a little bit on the tips of the boots here, but the whole point of dielectric grease is that it doesn't conduct electricity. So people take it and gob it up on the end on your actual contact points, which what you want is you want it around your contact points so you don't have any external source where you might like leak some voltage or try to pick up a ground somewhere else. But people put it all over their contact points, and then you get just a bad connection. Then basically you're making a point that has a high voltage drop now from your grease. I mean, I don't know how often that would ever catch you in the butt there where where it actually gave you problems. But I think it's a common thing. I don't think a lot of people know what dielectric grease is, or what it's for. Nice little snap. You want to hear that. Number 3. There's our snap. And these wires don't. Why do I have 2 number 3s? Foolish. Look at this. I don't know if you guys could see that. It'll be upside down there. There's a number 3 right here on the actual wire itself. It says NGK spark plug cable USA 3, but the actual sticker for the bore number it's supposed to go into is 2, wrapped in a sticker there. Silly, right? I thought that looked a little out of sorts with the length of that cable. There's our pop. All right, now we do number 2. Okay. Almost looked number dyslexic there for a minute, didn't I? Now we can go ahead and put that engine cover back on. Normally they call it a beauty cover. I'm not so sure that applies in this case. But as they say, beauty is in the eye of the beholder. I think they say that. Somebody said that. I didn't say that. See, make sure we're not rubbing anything, pinching anything here. Some vacuum hose with a cutout back there. Okay. Your oil cap back on. What a silly design that is. You'd think they would design that so you could take the beauty cover off without taking the oil cap off. Okay. That's that. Okay, here we are. We just read our codes again after doing the erase. It looks like everything's cleared right now for the vent valve and for that intake manifold actuator. So hopefully we're good to go now. Once we get out and drive it a bit, we'll see if anything comes back. And then next thing we're going to do is we're going to go ahead and try to tackle this EGR code that we have. Okay, guys, we're looking at that EGR code. Now, I'm here at the computer. This is like the best thing that you can do for any code you have or any, is just start with the manufacturer's specifications of what they want you to do. So this here is all data. I'm just going to go to trouble codes. We're a P code is what we're looking for. Like I say, I don't know what you can see here. I hope this comes up clear enough for you. And it's a P0405. So here's our P0405. And there you go. This is everything right here. This is what, like if they were at the dealership looking at your car, this is exactly what they would look at. You get the description here of the circuit. It's going to tell us how it works. But so I'm going to go ahead. I'm not going to like bore you with just reading this, but I just wanted to show you this quickly to see that this, like, mechanics aren't magic. We don't just memorize this stuff for every single car. You go to the data and you read it. You find out how a circuit operates, but we know the basics of how different types of circuits operate. But then we see how this one works, and then we can go ahead and troubleshoot from there. And then you even have right here on this side, this is just your action steps. It's telling you exactly step 1, check this. Step 2, check that. Okay, well, did this happen or that happen? If this happened, go to this step. If that happened, go to that step. And then you just follow along. All right, guys, here we go. It's the last code that we have to deal with here. Just for a reminder, you can see that it is a P0405. I think my camera's flipped there, but it's the EGR sensor A circuit low is what that code is for. Now, It's simple to just see an EGR code and kind of have that throw us off and maybe start looking at the valve itself, leading down a route that just has us chasing our tails. But there's a key word in that code, the EGR sensor A circuit low. So that sensor is kind of the key word. Now our EGR valve, we've got a power supply and a ground, and that actually makes the valve function. Now I already did it. I don't need to show you that probably, but I went ahead and just checked the valve for operation by manipulating it with our bidirectional control there. I just opened it 100%, started the car. The car ran like a bag of garbage, sounded like it was wanted to stall. So we knew right away the EGR was open and it functions. And then I went ahead and manipulated it up and down just to confirm that it was actually moving. But the sensor circuit is what feeds back from here to the computer, and that tells the computer the actual position of the valve. The computer knows the signal that it has sent, the desired request for how much it wants that valve to open, but then it has another circuit coming back that is a reference to tell the computer whether it has achieved that value or not. Now, that's what this code is telling us, is that we have a low voltage on that circuit, on this feedback from the valve to the computer. Now, there's a couple of reasons you could get that. Number one being that, well, the valve is stuck and it's carboned up or whatever, or it's just not functioning. It's not opening. So then what would happen is we would just get a voltage reading coming back to the computer to tell it that it's not open, which would be a low voltage. We've already confirmed that that works though. So the other thing that could happen here is we could just either have a broken wire on this circuit, or we could have a short to ground on this sensor wire. I'll have to reconsult my wiring schematic here. I'm pretty sure it's the blue wire. I'll get you up close when it's time to do it here. And let's just go ahead and check for voltage on that sensor wire and see what we actually get. Because if we actually have voltage right here, then we can check closer to the computer. And if we have 0 down there, or we have a lower reading than we have here, then we know somewhere along the way we have either a short or a broken wire. And then we can either tear this apart or just do a cheap layover and fix it from there. But if we don't have any voltage here right at the connector, well, then the valve itself might just be bad. Even though we confirm that it works, whatever is sending that signal into the sensor wire inside the valve could be bad itself. And then it's just, you're going to replace the valve. You're not going to repair that or anything. So I'm going to go ahead and reconsult the wiring schematic, and let's take some voltage readings. All right, guys, I tried to set you up with a closer view here. Just confirm my wires. Now, of course, they just want to make this tricky. There's 2 green wires. We got a blue, which is our control, a green and white, and a brown. Now, I went and looked at these there just to confirm, but this first green one is our low reference, and then this second green one is the one we want. That's our sensor circuit. So I'll just go ahead and gingerly back probe that and give us a ground here. So there we got 0.035 volts, which is essentially negligible. Now I've got the bidirectional control set up here. It's currently at 0%. If I can get that in just where you can see it, but just go ahead and start opening that up. There's 10%. I don't know if you can hear anything on the camera there. There, just made a little pop now that we're requesting 20%. And you can see as we're going up, I think you can still see that in the back. Our voltage is almost not changing at all. So we'll just go ahead and work this thing right up to 100%. And see, we're getting very, very minute, tiny changes on that circuit there. %, so it's still making its way. There's our 60. A little bit of a delay between sending the command and getting the result. Request of 80, up to 80. All right, let's go to 90. 90. And there we are. There's 100% requested. And we got 100% on the valve. So our voltage has changed a mere 0.025 volts. I'll confirm the spec on this, but I don't believe that's right at all. So I'm pretty much going to be able to condemn the valve right here, right now, without doing any more checks, just like that. Unless for some reason we had just a really bad connection here right in this connector for some reason. But I mean, I'll go ahead and unplug that and just take a quick visual inspection of the pins and stuff. But like, unless we got a pin missing out of this, or it's just totally, you know, it's hacked off or corroded or something like that, I'm pretty much just going to go ahead and call this valve no good. Unfortunately, you can't repair the insides of these things because the valve itself does work. We already confirmed that. But yeah, I think that's about it. So let's change out this valve. I'll have to order one and come back at you as soon as I receive it, and then we'll confirm that, fix our issue. All right, and just like that, we are back. Go ahead and unplug our plug off the EGR valve there. So not a brand new one. I just happened to be at the old parts yard there again. Grabbed a used one off another vehicle for now. So hopefully we don't have the same problem with this guy. It's always a gamble when you're getting used parts at the yard. And this one's nice and simple. It's just two 12 millimeter bolt heads here. And I actually, off camera, had just pulled this thing off. I knew I didn't have a problem with the valve itself, so I had pulled it off just to go and whatever, clean it out while we were in here, just take a look and make sure it wasn't carboned up. And wouldn't you know, one of the bolts broke. So that was fun. I tried everything to get that out, aside from welding a nut head on it, and then I was out at the pick and pull anyway, and this thing's just on there with a spacer onto the block, the engine head there. So I just robbed one off another vehicle at pick and pull for that too, and I swapped that out the other day, the new spacer. So let's get some bolts back into this. This is easier if you remove the ignition coil, but let's go ahead and drop the bolts into this thing first. Get them lined up. Got a few threads started there. There, I'll just tighten these up and we're all done. And we can go ahead and we'll run the same test on this one. We'll first things first, we'll hook up the scan tool again, and we will just observe if we are getting a signal voltage like we were expecting to have on the original one, which is what causes that code in the first place, is not having a sensor voltage. So that's just the first thing we'll check. And obviously, if I guess I won't bother doing the same test. If that's good, then we know we're good. So there we go. Let's get the scan tool out, get set up. All right, we got the scan tool set up here. Now, you guys were paying attention, right? You can confirm I didn't go ahead and just stick the old EGR that I removed right back on, right? So we should be able to, we should be good here, or at least know that. Oh, look at that already. EGR position sensor. There's our voltage right there. That's exactly what we're looking for. We never ever showed anything on this with the old valve. Just get her right up there and confirm that this voltage keeps going up. Funny thing, in all the reading that I did and all the specifications, I couldn't actually find a range for this voltage. I know the low reference is 5 volts, so it's something under that, but still didn't give an actual voltage range. Yeah, there we go. We're 50%, and this is about what I assumed, is that your range should be somewhere in the neighborhood of 5 volts, right? So 2.35 volts right there at 50%. So let's just take her all the way to 100 and just see what we get. So is that leg like we talked about? Let's play some Jeopardy music here for you guys. Come on, there she goes. And one more move, 100%. 4.3 volts, perfect. So we're seeing it move through the range like we want. So let's just go ahead, get out of this, and we will clear the codes. And then once this restarts, it'll do a bunch of checks on itself after codes have been cleared. Usually it will do just a 1 check on itself when you first start, but if you've done a code clear, it'll do 9 to 12 checks, I believe, just to get itself a baseline. And well, you guys don't need to see me back this off, so like I say, I'm going to go ahead and clear the codes, and then we'll just make sure this light doesn't come back. All right, guys, I got great news and not so great news. The great news is I've driven this a few thousand miles now. The check engine light is gone. It's stayed gone. So all those repairs that we did, they worked out great, and I'm pretty happy about that. So we had lots of good progress. Now the not so great news is that the fuel mileage is still terrible, and it's getting worse, actually. So I suggest right now, go down below, subscribe. Don't miss the update to that, because we are going to get this fuel mileage issue fixed soon, very soon. So if you want, I hope you come back and join me for that one too, but thanks for joining me on this one there. We cured a bunch of issues. I'm all happy. And next we're going to tackle that fuel mileage, like I said. So come back next time, and but thanks for tuning in today. See you later.